So far in this chapter, we've studied everything we can think of about functions. We've looked at the graphs of functions, we've looked at piecewise functions, we've solved functions, we've put functions in our graphing calculator. Today's video is going to be focusing on the transformation of functions, specifically the interaction between how a function shifts on a graph from left to right or up and down or a reflection, and what that looks like in the actual function rule or in the equation. By definition, a transformation of a function is changing the size or location of the graph. We're only going to focus on changing the location. Changing the size of the graph is something that's a little bit more advanced and you'll look at in Algebra 2. You'll also study that a little bit in geometry. So, let's get right into the rules. The rules of our transformations. First, transformation of a function, you can see I have two different functions down here, is shifting it, taking the entire graph and moving it, either up, down, left, right, or a combination. If I am shifting it from left to right, I am making a change in my x. So I would be either adding a number to my x value or subtracting it directly to the x value. So we look at the function this way, f of x plus c. Now, it's a little bit more confusing than you might think, because we normally think that if we are adding, then the rule is that's positive, we go to the right. But in our transformations, it's actually different. If we add a value to x, f of x plus c, we're actually going to shift our graph left, however many units we are adding. And then the opposite is true. If I am subtracting a value from x, that's when I'm going to shift the graph to the right, however many units I'm subtracting. So, as an example, if my function is f of x and I am adding 3 directly to my x, so inside my parentheses, adding 3, adding a value shifts it left, means I'm going to shift this graph to the left 3 units. How we do that? I'll go to every ordered pair that's plotted and shift it 1, 2, 3 to the left, shift this one 3 left, shift this one 3 left, and shift this one 3 to the left. Once they're all shifted, you do have to then connect those dots again, and you can see I have taken this graph and I have just slid the graph over 3 units to the left. The opposite would be to add or subtract 4. Subtracting from x means to move it to the right. So this would be a shift right 4 units. 1, 2, 3, 4 units here. 1, 2, 3, 4 units here. You can see that connects. I've taken this segment and shifted it to the right. 1, 2, 3, 4 units here. Those connect. I've taken this segment and shifted it 1, 2, 3, 4 units right. I've shifted the whole thing 4 units to the right. The rules for up and down are a little bit more straightforward, which then again confuses the issue. Okay? But now when I'm shifting this up or down is a shift in the y direction. So we want to recall that f of x is the same thing as y. So at this point, I'm going to be either adding or subtracting to the function, to f of x. I'm doing this outside of the parentheses. And adding a value to the function, or to f of x, shifts the graph up. Adding it outside the parentheses shifts it up. Subtracting it outside the parentheses to your function, not to x, is a shift down. So plus 3 would be up 3. 1, 2, 3. 1, 2, 3. 1, 3. 1, 2, 3. Connect our dots. My graph has shifted up 3 units. And then minus 4 is going to be down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. Everything has just been shifted down 4 units. The only other transformation we are going to study is a reflection over the x-axis or horizontal axis. And when we do that, it's when we multiply the function by a -1, or we do a negative in front of the function. If we multiply by a -1, that shifts it. Essentially, we're looking at a line of reflection. That line of reflection being this x-axis in this case. For us, it'll always be that. It's not always that in algebra. It is in our particular Algebra 1 class, though. So when I see f of x, graph negative f of x, any point that's above the x-axis goes below. How far below? The same number of units. This ordered pair is 5 units above. 1, 2, 3, 4, 5. I shift it 1, 2, 3, 4, 5 units below. So this is 5 units, this is 5 units. This is 1 unit, I only go 1 unit below. This is 1, 2, 3, I go 1, 2, 3 below. Anything that is below has to move up. This is 1, 2, 3, 4, 5 units below. It has to go 1, 2, 3, 4, 5 units above. And the graph is now a reflection. Go ahead, pause, and reflect g of x here. So our new function, negative g of x, should look like this. I've reflected each point over the x-axis. It's the same units away from the x-axis, but on the opposite side. So the last type of problem we want to review in this particular video is actually writing new equations. If I want to shift the graph left 2 units, since it's left or right, it's going directly to my x, not to the f of x, and left means I'm going to add 2. So I write my new function, f of x, and here's the trick here. I am adding to x only. So it's going to be x plus 2, but since I'm doing it to x, I square on the outside. Okay, let me do that really quick again. My original function is x squared, but I have to add just to the x. So I replace this with a plus 2 to the x, and the exponent stays around the parentheses. Different than part C, where I am shifting this graph down 1 unit. Down 1 unit means it happens to the function f of x. Subtract 1. F of x is x squared. So this function I subtract outside. I subtract after I apply the exponent. Go ahead and see if you can come up with parts B and D. Hit pause, then unpause to check. So in part B, since it's up 5 units, I will add 5 to the function. The function is x to the third. I add 5 after x to the third. Part D, I'm shifting it to the right 8 units. That's subtract from x. So I subtract 8 from x, and then I put the exponent afterwards. Parts E and F are a combination of the first 2 examples. I have this function, but now I am shifting it right 4 units, which means I'm going to go x minus 4. So I have x, and I subtract 4. But then I have to apply that exponent of 2 and shift it down 7 units, which is minus 7 outside of those parentheses. There's my new function. You're going to try part F. Part G is a reflection over the x-axis. When I reflect over the x-axis, I multiply by -1. So my new function is going to be -1 times the original function, x squared. See if you can do part F and part H. Both are combinations. Be careful with part H. It's a reflection and a shift to the left. Pause, try them, and then unpause. So for part F, I add 2 to x because of the left 2, and I add 8 outside of the parentheses after the exponent because of the up 8. And for part H, I have a negative in front. I could have a negative in front or negative 1 times. Either one would be okay. So I could have this, but I need the plus 1 to x inside parentheses.